We often see wind turbines with just 3 blades installed in wind farms, and some of them are relatively small. But wouldn't adding more blades make the turbine generate more energy? Or wouldn't making it larger improve its efficiency? Today, I'm going to explain why wind turbines are the size they are and why their propellers have only 3 blades. Hello, engineering enthusiasts. We recently received an interesting comment here. Asterisk, I'd like to know why turbine blades are so thin and why there are only 3 of them. If they were thicker, or if there were more blades, wouldn't they generate more energy? I've always wondered about this. First, I'd like to thank Janio for this question, and let you know that if you also have a question like this, feel free to leave it in the comments. It's very helpful for us to create content tailored to your questions, and to connect directly with you. Now let's get into it. People have been harnessing the power of the wind for thousands of years, with the earliest recorded evidence dating back over 1,000 years in Persia. These machines have evolved from simple devices used to grind grain and pump water into enormous blades that generate enough energy to power entire cities. Traditional wind turbines come in many shapes and models, but they have converged toward a fairly consistent 3-blade design. But why do these wind turbines have only 3 blades? We can think of each blade as a wrench tightening a bolt, that if we increase the length of the wrench, we can generate more torque because this is exactly the force that causes rotation. Similarly, by adding a second wrench, we can apply even more force. The same principle applies to wind turbines, so naturally you might wonder, why not add more blades and make them longer? The largest wind turbine to date is the Mingyang Smart Energy, with a total diameter of 260 meters. It has a 3-blade design, with each blade measuring 123 meters in length. Despite being made of carbon fiber, each blade weighs about 54 tons. To give you an idea, the blade tip can reach speeds close to 70% of the speed of sound. But why not build the same turbine with more or fewer blades? Let's compare our standard 3-blade design to other models with 2 and 4 blades, assuming they have the same blade design. We know that every engineering project considers a cost-benefit relationship, and there is an ideal balance point over the lifespan of the wind turbine, that if we consider the production cost of wind turbines over their lifespan, there is a period during which the revenue generated by the turbine is used to cover its production cost, only generating actual profit afterward. If we add an extra blade to a wind turbine, we increase production costs and consequently reduce profits. This makes the 4-blade design impractical due to the high production cost. Thus, we are left with a 2-blade and 3-blade designs according to the Wind Energy Handbook. To achieve a performance close to that of a 3-blade turbine, we would need to either increase the cord length by 50% or increase the turbine's rotational speed by 22.5%. To clarify, in wind turbine blade design, the cord is the distance from the curvature radius of the leading edge to the trailing edge. Now, think about this. If we need to increase the cord length by 50% on each blade of a 2-blade turbine to match the performance of a 3-blade turbine, adding 50% to one blade plus 50% to the other essentially adds up to 100% in total. In other words, it would be like adding a 3rd blade, which makes increasing the cord length less advantageous. As I also mentioned, we could increase the rotational speed of the blade by 22.5%, meaning it would need to spin faster. That 2-blade turbines will rotate faster in the same wind due to the reduced drag they experience. However, the fact that they rotate faster isn't necessarily a positive aspect. In fact, it can be a drawback for the design. But why is this a problem? If it's spinning faster, wouldn't it generate more energy? Well, the design of a wind turbine considers multiple factors, and some key aspects include vibration, centrifugal force, and noise. A wind turbine spinning at higher speeds can create more vibration throughout the entire structure. This means that with higher speeds, we might introduce more vibration into the system, requiring stronger materials to handle the stress. That we've already made a video discussing the disadvantages of wind turbines, and noise is one of them. I'll leave a card for that video at the end of this one. In this analysis, we reached an ideal point with a design featuring 3 blades. These blades can generate more energy at lower wind speeds compared to a two-blade design, and they offer a better cost-benefit ratio than a four-blade design. That's why we only see wind turbines with 3 blades. The size of the blades is directly related to production costs. The blades are designed to have an optimal size that maximizes the amount of energy captured from the wind while considering material resistance and the structural limits of the tower. If the blades were larger, the extra weight could overload the turbine components and increase the risk of mechanical failures. Additionally, more robust towers and much more expensive foundations would be required, raising construction and maintenance costs. The saying 1 is little, 2 is good, 3 is too much doesn't apply to wind turbines. Perhaps it's better to create a new saying 2 is bad, 3 is ideal, and 4 is too expensive. If you made it this far and enjoyed the video, please consider subscribing. If you're not already a subscriber, give us a thumbs up and activate the notification bell. If you find our content interesting, think about becoming a member to help us continue producing content here on the platform and to be featured in our videos. Also, if you're looking for professional growth, I'll leave a link below where you can find various opportunities to develop skills that will make a difference in both your personal and professional life. So, did you know the reason wind turbines have 3 blades? Have you ever imagined having a version installed on your roof to generate energy? Have you seen one of these turbines up close? Let me know in the comments. I'd love to hear from you. On the side, there are 2 options for interesting videos you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, please give us a thumbs up, subscribe to the channel, activate the notification bell, and consider becoming a channel member. That's it, engineering enthusiasts. A big hug, and I'll see you in the next video.